Okay, so this is part 3 of the notes for inductive reasoning. We are looking at conjectures and counterexamples. So what is a conjecture? It is an educated guess that is based on examples in a pattern. Okay. Example 8. Here is an algebraic equation and a table of values for n and with the results for t. So t equals n minus 1 times n minus 2 times n minus 3. Okay, after looking at this table, Pablo makes this conjecture. So he sees the value of n minus 1 times n minus 2 times n minus 3 is 0 for any whole number value of n. So here he's got 1, 2, and 3. He plugs it into the equation. He says, oh, I'm going to get 0 every single time, no matter what value of n is. Is this a valid or a true conjecture? So he's looked at some examples here, and there's a pattern. He says, oh, if I put 1 in, I get 0. If I put 2 in, I get 0. If I put 3 in, I get 0. So that means if I put any other number in, 4, 5, 6 onward, I'm also going to get 0. So what do you think? Is this valid? So let's try 4. So if I put 4 into this table, I would get 4 minus 1. So let's do this. So t equals 4 minus 1. And this would be 4 minus 2 and 4 minus 3. So 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3 is 1. 3 times 2 times 1 is 6. So this would be 3 times 2 minus 1, 6. So no. No, if Pablo tried 4, or really any number greater than 4 or greater than 3, whole number, if he tried 4, he would see his conjecture is false. So what is 4? So he made a conjecture based on a pattern, but then we tried 4 and it didn't work. So 4 ends up being a counterexample. So what do you think a counterexample is? All right, so a counterexample is an example that disproves a conjecture. So it's an example that disproves or proves it wrong, disproves a conjecture. I should have put disproves in red. I'll just underline it here. Okay, so an example that disproves a conjecture. So 4 in that previous example disproved it, that conjecture that Pablo made. So let's take a look at example 9. Arthur is making figures for a graphic art project. He drew polygons and some of their diagonals. Based on these examples, Arthur made this conjecture. If a convex polygon has n sides, then there are n minus 2 triangles drawn from any given vertex of the polygon. Is Arthur's conjecture correct? Can you find a counterexample to this conjecture? So in this first one right here, he's got 3 sides. And so 3 minus 2 is 1, so there's just one triangle. And this one right here, we have a square, a rectangle, quadrilateral of some sort, and he can draw from any given vertex only one diagonal here, so he gets two triangles. So this would be 4n minus 2, so it'd be that 4 sides minus 2 equals 2 triangles. So here we have 5 sides minus 2 would be 3 triangles, and here we have 6 sides minus 2, we get 4. So it would seem to be true here. So let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a 10-sided figure that's called a decagon. And this is convex, convex polygon. A concave polygon, just so you know, would look something like this, where we have this vertex is inside what would be, if I can draw a diagonal from any other two vertices. This would be concave, like a cave, right? So convex, all the diagonals are inside. So let's see, how many triangles do you think I can make from a 10-sided figure? So it should be 8, right? So if this has 10 sides and I take 2 away, I should be able to fit 8 according to this conjecture. So let's start here. 1, 2 triangles, 3, 4, 5, 6, 7, and then 8 is his last one in here. So yeah, it seems to work. His conjecture appears to be true, but I can't seem to find a counterexample that works. It doesn't mean that there isn't one. There isn't one, but I just can't find it right now. So that's it. Try the practice set.